everybody. I am Professor Dill, and today we are picking up where we left off on vectors. So we're going to pick up with example 2.13. A jogger runs at a flight of 200 identical steps. Okay. 200, and then runs along the top of a hill 50 before he stops. So this vector is d a b equals 90 I. So that would make sense if it was going like this. D A B 90 I plus 30 J. I don't know if that makes sense either. So I'm not sure exactly if this drawing's correct. So what is the height of each step? Height and width of each step. Okay. Height and width of each step. So we want to find DAB equals 200 cosine. What am I going to say? This is 45 plus 200 sine 45. Okay, so that's our AB, and then we want to find 50. What is the height of each step? Okay, so we want to, so the height of each step would be our I. So 50 cosine 0. Okay. I'm not sure if this is even close, but we'll run with it a little bit. Okay, so 345 degrees. Okay. So 212. Components are 212. Oh, I missed a number. 200, 45, 45, 141. Equals 141. So that'd be I. Okay. And 50, 0 plus 50 I. Okay, so I'm wondering if we can find out what I is. So let's do 141 plus 50 minus 90. So this is equal to 101 I plus 191J equals 0. Okay, now we want to divide 200 maybe we shouldn't have added 50. I'm gonna neglect the 50. I don't think that makes sense. So we have a height of each step is 200 over 101 meters. And then the width of each step is 200 over so 2 meters for the height. That's a big step. I don't think that's right. 41, 1.5 meters. So let's see what the book says. So that was our attempt. I don't know if it was a very good one. Okay, so what is it saying? We have B, T, A. So it's saying the displacement of A, B. So that's that vector is the sum of D, A, T find the horizontal and the vertical components. Okay, so they wanted both. Okay. Therefore, the displacement vector is DAT would be DAB minus DTB. Okay, so we had 90 and 30 plus minus 50i. So the 50i, that's one thing we calculated right. And that's TB. Okay. So I feel like I'm having trouble following, but we'll get through it. Scalar components is 40 and 30. actual distance is 100. Alright, so that's kind of a tough problem, I would say. Now, many physical situations, you also need to know the direction of a vector. Magnetic fields. We have already said direction is given by a unit vector, which is a dimensionless entity. When the vector in question lies along one axis. T equals over I, the general rule of finding the unit vector of a direction for any unit vector is divided by magnitude. Okay, so I've seen this before. So the unit vector of V over magnitude of V. Okay, so if we have a vector plus so that would be so 1/2. So that's equals V. So unit vector of V is equals 80I plus 60J plus 2K. If you round off your partial answer too early, you can have a bad error. I don't like the convoy question, so I'm just going to skip that one. Products of vectors. So multiplying two vectors, multiplying a vector by a scalar. Okay, so this is called the dot product. Equals the sum I equals 1 to n of AI times B I is the magnitudes of A times B cosine phi. So if we have a vector 2, 4 dot 2, 4 dot 1, 3, that is 2 times 1 plus 4 times 3 equals 40, 12, 14. So how do you find the magnitude? Magnitude of a vector. So let's verify that's correct. Okay. Um, 68. 2 times square root of 5. 2 times square root. Alright, I don't know what I'm doing, so let's return the book. Two parallel vectors is cosine 0. Vector squared is a times a squared. Okay. Okay. Example. Find a dot f. Okay, so it is 10 times 20 times cosine a f. Okay, I'm not going to look for that figure, but we'll just say it's given 75 degrees. I think in Senpai it might just be 10 semi vector dot product example. Yeah, I need to run this. Insert below. Okay. Okay, so this is a lot different dot product than what I'm used to in just abstract linear algebra. Um, Scalar products are the unit vectors of the axis. Okay. See, I don't really like uh, square it, and then so okay. So to find the magnitude, you take each component. So if vector v equals v1, v2, vn, then the magnitude of v is square root of the sums. So it's like a so n-dimensional Pythagoras theorem lets you find the vector. So that's why the magnitudes of these unit vectors are 1. Okay. A times b is ab cosine phi. Scalar product can also be interpreted as the product of the projection A of vector A. So I should find my book, but my textbook, another textbook I've used is they'll write projection like a function. Projection of A onto V is how the book and other books write it. So dot product can be defined as other different products. And what is a projection vector? So scalars of vectors are commutative. So A times B equals B times A. Now these are one-dimensional matrices, and this is not true for matrices. So if you have, maybe it is. I know matrix multiplication is not commutative. Okay, so check our understanding. A is AX, magnitude of A in the X direction. And A AK equals AZ. Okay. So A times I equals the magnitude of this A I cosine phi. Okay. $2.29. Okay. 2.3. So this is also I magnitude of A cosine phi, or equals B I magnitude of I A times projection of A, or magnitude of A times projection of I. All right. Show AI equals AX. AX times 8. Man. So cosine phi is A times B over the magnitudes. So I've seen this derived in another place. So angle between two forces. So three dogs pulling on a stick in different directions. So we have a vector going this way. One going this way. And one going this way. So what's the angle between force 1 and 2? So what's this angle? Newtons. F2 is 15I minus 6.2 K newtons. So we want to know phi. I'm guessing this is phi. So that's going to be okay. And cosine. So we need to know dot product. So that's going to be so AX. Okay, so AX so it's 10, 90 degrees. So it's going to be 0, plus AY, BY, FY, BY. So plus 0 plus 2 2 2 times cosine k. So k is degrees. Yeah, I don't think the book's explaining this well at all. Okay, so what is it saying? It's saying 10 negative 150 plus 0 minus 12.4 so that should be divided by 22.8 times 16.2. So negative 162.4 128 equals okay. Phi equals cosine negative 1. I'm s- I'm so kind of blown away how different the conception of the vector of the dot product is. Because like I'm used to thinking of vectors as lists of numbers. Um, and obviously, like if vector v is 2, 4, where this is x and y equals 2x plus 4y, y equals negative 2x. So you would have a negative slope line, 2, 4, 2, 4, 2x plus 4y. So negative 4y equals 2x. Y equals negative 1/2 x. Okay, anyways, let's because I used to think like vectors, it was like 2, 1, 2, 3, 4. So your vector would be this. It wouldn't say direction, but direction is always, but we assume it's on, goes to the bank from the origin that way. But these vectors are a little different. They're more like vector v is defined as 2 squared plus 4 squared times I hat some unit vector. Well, that would be the magnitude of that. This is more saying to what do we cosine angle? The magnitude is 2 squared plus 4 squared. So how do you write this in terms of I hat? It'd have to be like equals 2 I hat plus 4 j hat. Okay. Now what's the direction in degrees? That would be 4 over 2 inverse tangent. It's 26 degrees. Is what I'm getting for 2, 4. Let's find my components. $63. 2, 5. Well, it doesn't say where they use the 2, 5. We're still taking tangent of this. So it should be 63. Why isn't set correctly to calculate angles between the vector? Two, 4. So TOA converted to degrees. I'm so confused because I have two conceptions of vectors in my head that I'm trying to reconcile them. Okay. Force F. Pulls on object. Okay. Amount of work the force does is a scale product. So another way of saying this is F dot V is F1 times D1 for all n, and F is defined as a vector with coordinates How is a vector 5I hat plus 12J hat rest as okay equals 5, 12. Each component represents magnitude of the vector, the x direction. Okay. Is that like saying 5, 12 times y? Okay, so it's saying this is equal to 5x plus 12.5y. Okay, cross product. Vector AX is perpendicular to the plane. So we have a plane cross product. It's supposed to be like that. And that's just a number. Nope, it's a vector. Okay, I see. A, B, sine, theta. This is a vector because it's got a magnitude and it's got a direction. Okay. Okay. A, okay. Let's do an example. Mechanical advantage that a familiar tool called a wrench provides depends on the magnitude F. So, like, I don't get why they say mechanical advantage. Why doesn't it not just say work? Um, so torque is tau. Torque is tau vector. Torque is cross product of these two vectors. So R and then F and then phi. Okay. So to loosen a rusty nail, 20 Newton force is applied at 40 degrees, 25 meters. So 20, Alright, I should have remembered this. And then had the 20 right. Sine 40. So what I don't get is it's saying this is 3.21 joules, but the answer is not a vector. So the cross product is a vector or is not a vector. Why is the book saying it's not a vector here? Because AB sine phi is a number. It's a number times a number. This doesn't have a direction. So this is saying it's not a vector. But then it's saying the cross product is a vector. And then it gives me a number. So I don't know what this book is saying. Now it's saying it's just a number. So the book's telling me one thing and then yeah. So cross product has distributive property. I hat cross I hat equals zero. All of these is zero. I cross J equals K. J cross K equals I. K cross I is J. I J K J K J K K I J J K K I J. Okay, now I want to know is if J is K cross I, then is that equal to I cross K? So then here we have to consult our properties. So it had to be negative I because this cross this is equal to negative I cross K. If the book's right, so K equals I cross J can be written as negative J cross I equals J cross K equals negative K cross J. All right, I'm gonna end it there, everyone. Thanks for hanging out. Next time we'll pick up where we left off, page 82.